everyone, Katrina here, and today we're going to go over the 3 cases of lines and planes intersection. Please subscribe for more videos just like these. So we're going to dive in. I'm going to tell you the 3 different ways that lines and planes can intersect, and then we're going to go into 3 examples that highlight each of these unique types of intersections. So the first way that a line and plane can intersect, and again, I just wanted to note that we are living in R3 right now, in 3 space. So they can either intersect, so that means they're going to have one point of intersection, so basically a point that they share. They can be coincident, so that means that the line is actually on the plane. So that means that there's going to be an infinite amount of points of intersection because everywhere, at every point of the line, there's going to be a point of intersection because that line lies on top of the plane. And lastly, our lines and planes can be parallel and distinct. So that means that the line is either like above or below the plane. Sorry, that's not how you spell below. Plane, and you're going to have 0 points of intersection. So if we kind of draw these out for like situation number 1, you would have your plane, and then you would have your line that would like go right through your plane kind of. So it's a bit hard to see in 2D, but you're going to have that one point where it crosses over. When it's coincident, that means it's going to be on the plane. So if you have your plane over here, you can see that your line is going to be on your plane. So every single point, it's going to share. And then lastly, if you have your plane over here, for example, your line is going to be parallel, but it's going to be like above, so that as it goes on for infinity, it's never actually going to cross through the plane. So we're going to go through a series of 3 examples where I'm first going to show you an example where they intersect, an example where they're coincident, and an example where they are parallel and distinct. So please stay tuned, and again, if you're enjoying this, I'd really appreciate it if you subscribe for more. Okay, so we'll do example number 1. So our question is, do they intersect? So we want to find if they intersect, and if so, what is the point? So what point? Okay, so let's see what we have here. So our plane has the equation of x plus y minus z minus 6 equals to 0. Or we can rewrite this immediately so that we have equals to 6. Either way is fine. So this is the scalar form of the equation for a plane. And now we're going to write the equation for our line. So we can just call this R1, and we have it written in vector form. So we have x, y, z equals to 8, negative 1, 4, plus t, then 3, 0, negative 1. Okay, so we want to figure out if they intersect and at one point. So step 1 is always going to be convert our line into, parametric form. So this is important here because it allows us to do some more manipulations with the equation. It's a bit more of a flexible form, the parametric form. So let's go ahead and do that. So our line now becomes, we've got x equals to 8 plus 3t, y equals to negative 1 plus 0t, and then z equals to 4 minus t. And if it's y equals to negative 1 plus 0t, we can just erase that t over there. Okay, so now that we have this, we want to then, as a step 2, we want to sub into our plane. Okay, so let's go ahead and do that. So if we sub this into our plane, what do we get? So we're going to take all of this, and now we have, so x equals to 8 plus 3t. Okay, so we're subbing it into this equation over here, and then plus y, which is negative 1, and then minus z, which is 4 minus t, and that equals to 6. So essentially what we want to do now is step 3 is we want to solve for t. And solving for t is going to give us kind of that point of intersection between our points. Okay, so let's go ahead and simplify this equation then. So if we expand it, we've got 8 plus 3t minus 1 minus 4 plus t equals to 6, which gives us 3 plus 4t equals to 6. So then we have that 4t equals to 3, and then t equals to 3 over 4. Okay, now we go to our step 4. So we want to sub t equals to 3 over 4 into our R1. So we want to find what are the values for x, y, and z that work. So x equals to 8 plus 3 times 3 over 4. And this equals to, what do we have over here? 41 over 4. Y equals to negative 1. And z equals to 4 minus 3 over 4, which equals to 13 over 4. Therefore, we have our final answer that the point of intersection between the line and the plane is at 41 over 4, negative 1, and 13 over 4. There we go. So that is our example number 1 and done. Comment if you have any questions about that. Okay, so let's move on to example number 2. So here we have the plane. It's the same question. We want to determine whether it intersects, and if so, what's the point? So the equation of our plane here is 3x minus y plus 2z equals to negative 6, and the equation of our line here equals to x, y, z equals to 1, 13, 2 plus t times 1, 1, negative 1. Okay, so let's see what we need to do. Like I said, we always are going to start. So 1, we want to put it in our parametric form, and essentially we're testing the intersections here. So we have that x equals to 1 plus t, y equals to 13 plus t, and z equals to 2 minus t. So we got this over here. And now our step 2, like before, is we want to sub into our plane. I honestly love intersections of lines and planes. I feel like they're quite straightforward compared to some of the other stuff in vectors. So here we just take this and sub it in. So we've got 3 times 1 plus t minus 13 plus t plus 2 minus t equals to negative 6. Okay, so if we expand this out, we've got 3 plus 3t minus 13 minus t plus 4 minus 2t equals to negative 6. And then as a result, we get 0t minus 6 equals to minus 6. So we have that 0t equals to 0. What does that mean? That's kind of like a 0 equals to 0 situation. And if you've seen in my previous videos, whenever we get this, that means that there's going to be an infinite, infinite values of t. So if 0t equals to 0, that means that t can be absolutely anything, right? Because this 0 in front of it over here is going to make this equation true. So if there's an infinite value of t, that means there is going to be an infinite value of intersection points. And if there's infinite value of intersection points, we saw from our initial summary that means that we are having a situation that is coincident. Which means that our line lies on our plane so that there's an infinite amount of intersections. Okay, our last example, which I think we have a bit of an idea of what it's going to be. Again, we want to determine if it intersects, and if so, where. So the equation of our plane is 2x plus 3y minus 4z equals to negative 7. And the equation of our line in vector form is x, y, z equals to 4, 2, 5 plus t, -1, -2, -2. Okay, we should know the steps by now. So first, we'll put that in green. So first we want it in parametric form. So we're going to rewrite the line in parametric form, which gives us x equals to 4 minus t. Then we have that y equals to 2 minus 2t, and then z equals to 5 minus 2t. Step number 2, we want to sub our parametric form into our plane. Okay, so we get 2 times 4 minus t plus 3 times 2 minus 2t minus 4, 5 minus 2t equals to -7. And so if we expand this, we get 8 minus 2t plus 6 minus 6t minus 20 plus 8t equals to -7. And now we have -6 plus 0t equals to -7, so that we have 0t equals to -1. Oops. This is another strange case. This is a 0 equals to -1 case, which mathematically doesn't work. So that means that we can see that there is no value of t that makes this true. Okay, so that makes this true. So if there's no value of t that makes this true, that means that there's no solution. And what did we learn? Well, if there's no solution, that means that the lines aren't intersecting, or the plane is not intersecting with the line. So what option does that give us? That means that the line and the plane are parallel and distinct. Okay, so hopefully this video gave you a pretty good summary of understanding the intersection between lines and planes in 3 space. And I showed you the 3 different options where they could intersect or not intersect, how to solve them algebraically, and also kind of what forms to look for. Looking for that 0t equals to 0 form would mean coincident. If you have 0t equals to some other constant, then that would mean that there is no solution, therefore parallel and distinct. And if everything works out and you get a value for t that works and you can sub in, then that means that you do truly have a point of intersection, and you can go and sub that into your parametric form to find the value or the coordinates for your x, y, z, which will be your point of intersection. So I hope you enjoyed that video. If you did, please drop a like and comment any questions that you have. Definitely subscribe for more videos. I'm going to have many more videos on vectors coming out, and definitely check out the ones that are there already. I look forward to seeing you next time.